Madhavan sir, welcome.
Welcome. Update
sir. Romalaji sir, how are you?
After you have to keep up time. Next time I will not be available if you are delaying. Okay.
Hello. చెప్పండి. ఎక్కడి నుంచి? ఏం లేదమ్మా, థ్యాంక్ యూ.
Kathmandu.
Connected. Align connected. Harmonic 76. The garden meeting, right? The course meeting.
Dr. Jageshwar sir, 5:35 will start. 5 minutes will wait. Some more people are joining. Yeah.
Okay, sir. I'm ready, sir.
Right, sir. Thank you. Thank you. Yes, Dr. Jaykrishna, shall we start? Right. Happy good evening to everyone. Am I audible, sir? Raju,
Yes,
sir?
sir.
Okay, sir. Happy good evening to everyone. Today we have an interesting topic which is going to be delivered by an eminent personality. That is Dr. Jaykrishna Kandasamy. The topic is about sustainable transformation in manufacturing. In today's world, we have to give this world to the future generation. Anything, whatever we do, we should be eco-friendly. And SDG, our United Nations have the 17 SDG goals. And whatever we do, whether it is manufacturing, whatever we do in our society, whatever we do, we should take care of the environment around us. So, with keep in mind, our Dr. Jaykrishna Kandasamy, Associate Professor, School of Mechanical Engineering, Vellore Institute of Technology, University, Vellore, Tamil Nadu, is going to deliver the topic on the sustainable transformation in manufacturing. We have an earlier link with today's speaker. He was awarded Young Engineers Award during the 34th National Convention of Production Engineers 2019, which was conducted by our Institute of Engineers India Untitled Chapter and in association with the headquarters of IEI headquarters during the convention in the year 2019, the May month of 25 and 26. First of all, I welcome our today's chief guest, that is Speaker of the Day, Dr. Jaykrishna Kandasamy, who really agreed to deliver a webinar in our IEI TLC platform and address all our IEI TLC members and also the other 5 professional institution members. Thank you, Dr. Jaykrishna, for accepting our invitation.
Thank you, sir.
Yes, sir. I also thank our other professional institutions housed in our 3,000 acres BHL campus, Trichy campus, who is associating and joining with IEI Trichinopalli Local Center in today's webinar, namely the campus Trichinopalli chapter, and the Indian Institute of Welding, Trichinopalli chapter, and the Indian Institute of Industrial Engineering, Trichinopalli chapter, the Indian Institute of Metals, Trichinopalli chapter, Indian Welding Society, Southern Zone. I welcome all the office bearers and members of the other professional bodies who joined today. As per IES TLC is concerned, we are conducting the regular weekly Tuesday program, the lecture program on Tuesday for the first 3 decades. It was in the physical mode before the pandemic. That is before April 2020, we were conducting all the programs in physical mode in our Dr. APJ Abdul Kalam Hall, who is having AC hall, is having seating capacity 100, and we have one more auditorium which is having a seating capacity 300. When a big program we used to conduct that. After the pandemic, we switched over to the virtual mode. That is from April 2020, and this is our 1/10th program actually. This one. The main advantages are we are able to bring the experts around the globe. And also the participants also all over the world, they are able to participate. We IEI TLC with the Association of Other Professional Institutions regularly propagate the emerging and latest technologies to all our members, students, industrial professionals, and to our society and all the engineering colleges around us. Our boundary is right from Ariyalur, Karur, Ariyalur, Perambalur, Pudukottai, till it goes up to Thiruvarur and Nagapattinam district, except in Tanjavur. This is our boundary, and we propagate. We have regular programs with our all the member colleges, student chapters are there. We conduct regularly weekly lectures, workshops, and all India seminars, conventions, etc. These all also our headquarters funding our education institution in R&D funding and all is going on. Like that, we do a lot of activities. We visit our IEI TLC website, IEI headquarters website. You know what are the activities done by our. We have more than 250,000 corporate members and student members about 10 lakhs. This is what our profile of IEI. With this brief introduction, I call upon Raju, Mr. N. Raju, Honorary Secretary, Indian Welding Society, Southern Zone, to welcome the gathering. Over to Mr. Raju. Raju, sir?
Yeah.
Yes,
Thank you, Selvaraj.
Yes, sir. Yes.
Thank you, Mr. Selvaraj.
Yes, sir. No mention, sir. Please.
Respected speaker, Dr. Jayakrishna Kandaswamy, members of professional bodies in BHL Trichy complex, invitees and attendees. A very good evening to all of you. The Institution of Engineers joins hands with Computer Society of India, Indian Institute of Welding Trichinopalli branch, Indian Institution of Industrial Engineering Trichy chapter, Indian Welding Society Southern Zone, and Indian Institute of Metals Trichinopalli chapter in organizing this lecture on sustainable transformation in manufacturing as a part of its knowledge sharing objective. The lecture will be handled by Dr. Jayakrishna Kandaswamy, Assistant Associate Professor, School of Mechanical Engineering, Vellore Institute of Technology, Vellore. On behalf of all the professional bodies, I extend a warm welcome to the speaker. I welcome you, sir, in a special way. At the outset, my sincere thanks to the speaker for having accepted our invitation to be with us this evening and deliver the lecture. I deem it a pleasure to invite all the participants present on this occasion, and I wish the participants a purposeful evening in listening to this lecture. Thank you.
Thank you, Dr. Raju, for overwhelming welcome address, and welcome to everybody, and also importance of today's topic. Thank you, Raju, Dr. Raju, for your welcome address. Now move on to the next agenda. I call upon Dr. S. Titus, our management committee member of the Institute of Engineers Local Center in the electrical division. I request him to introduce a speaker to the audience. Over to Dr. Titus, sir. Titus, sir, please. Sir.
Thank you, sir. Thank you. So thank you so much for the opportunity given to introduce today's eminent speaker, Dr. Jayakrishna Kandaswamy. I'm happy to introduce the today's speaker of this event, the seminar on the title Sustainable Transformation and Manufacturing. Dr. Jayakrishna sir is an associate professor in the School of Mechanical Engineering at the Vellore Institute of Technology, University in India. Dr. Jayakrishna sir's research is focused on the design and management of manufacturing system and supply chain to enhance the efficiency, productivity, and sustainability performance. And more recent research work is on developing tools and techniques to value creation through the sustainable manufacturing, including the methods facilitate more sustainable product design for closed loop, so in the industrial symbiotic setup, and also developing sustainable product using hybrid biocomposites. Also, a mentored for the doctoral students, research scholars, graduates, and undergraduate students. He has completed produced two PhD scholars and two MTech scholars, and also he has more than 31 BTech theses, and which was so far led to 66 the leading SCI journals, Corpus indexed journals, and 26 book chapters, and 91 referred conference proceedings, and also 7 books in CRC Springer series. Dr. Krishna sir team has received numerous awards in recognition for the quality of the work that has been produced. He teaches undergraduate as well as the graduate courses in the manufacturing and industrial area, and his initiatives to improve the teaching effectiveness has been recognized through the national awards. Also been awarded Global Engineering Education Award from Industrial Engineering and Operations Management Society International USA in 2021, and also Institution of Engineers India Young Engineer Awards in the year 2019, and a Distinguished Researcher Award in the field of Sustainable System Engineering in the year 2019 by International Institute of Organized Research, and also a Best Faculty Researcher Award for the year 2016-2019 as a coordinator for the Circular Economy Club in the VIT University, and academic editor for the Mathematical Problems in Engineering, Wiley Indavi Publications, and editorial board member, and a Journal of Operational Research for Engineering Management Studies, and also is an area editor for Operation Management Research, associate editor in Circular Economy and Frontier in Sustainability. So, sir, Mr. Dr. Jayakrishna Kandasamy, sir has a very good experience in teaching, has more than 8 years in the teaching field, and has a industrial experience more than 1 year, and he has a research experience more than 3 years, and he has published a number of books and published a number of journal publications in journals, in reputed journals. More than 66 papers are presented in the published in the international journals, and all the journals are highly indexed. In H index is having 15 and I index 26, and he is also a author for many books. For more than 4 books he was author, and he has edited many more than 3 books, and 7 books are in progress, and he has written book chapter for more than 27 chapters, and he has a editorial member for 3 journals, and also is act as a editorial member in the international conference for more than 91 conferences, and he has got more than and he has applied 4 patents in his area of research, and the total citation is having is 1358, which was very much appreciated. I think today we have a very eminent and very expertise person in the area of this today's topic. With this short notes, I welcome you, sir, for your valuable presentation. Thanks for the opportunity, sir. I thank the Selvaraj sir and all the committee members for the opportunity given for me. Thank you, sir.
Thank you, Dr. Titus. Thank you for an excellent introduction of the today's speaker. Now, I welcome all the invitees around the globe who has come and participated in our today's webinar. Thank you so much. And I call upon Dr. Jayakrishna Kandasamy to deliver his webinar, sir. Please, over to Dr. Jayakrishna, sir.
Thank you, Selvaraj sir. Thank you, Titus sir. Thank you, Raju sir, and for giving me a brief introduction about myself. I'm proud enough to be a part of IEI. I'm also IEI member, and I even received IEI award as mentioned by you all. Thank you so much. Now I'm going to share my slide. Can you just confirm whether the slide is visible?
Yeah, sir, it has come. You have to make it full mode, sir. Full mode.
Yeah. Yeah.
Yeah, now it has come full mode, sir. But thank you. It's precise, visible, sir.
Okay. Yeah, thank you so much. Sir, if there is any technical glitches are there, please let me know so that I will stop and we can recover and I will continue.
Sure, sir. Sure, sure,
to
sure.
Thank you, sir. Thank you all, my seniors, my mentors, everyone, for giving me this opportunity to present in front of my own community, IEI chapter, Trichapalli chapter. And today I will be presenting my topic on sustainable transformation in manufacturing. So I'm proud to be associated with this association. As you all know, I did my PhD in NIT Trichy, where I got to know a lot about BHL and its operations during that time. And for today's agenda, we are going to discuss about sustainable manufacturing and its transformation. To make it interesting from the industrial point of view, I'm going to use a lot of use cases here. So first I'll be presenting about sustainable manufacturing, some of the case studies on sustainable manufacturing. Then what are the industrial challenges we are facing and how IoT we are going to apply and what are the use cases of this. So how sustainability and industry 4.0 transformation is going to happen, we are going to do. So after that, I'll take up some question and answers from the audience and from my boss. Okay, so why manufacturing needs to be sustainable? So we have been keep on hearing this word sustainable manufacturing or sustainability, sustainable development many times, anywhere, at many places. So basically why this is required. Okay, so this is required because the environmental regulations are are becoming stringent, and it is forcing us to change towards eco-friendly manufacturing practices. We are not customers, or even the millennials, the modern day customers, the recent customers, they're looking for eco-friendly products. They're asking for 5-star rated refrigerators, 5-star rated air conditioners. Such awareness is there among the customers. Not like not like our grandfathers. Nowadays, customers are looking for sustainability in the products, or what you call eco-friendliness in the products. Next, as a manufacturing organization, as industries, what we are looking, our organization is always looking to produce more with less. It was wrongly written here. It's about produce more with less. That is, we are going to produce more amount of products with less amount of consumption of materials and energy. Okay, I'm going to give you such a short definition of sustainability. This word sustainability was first coined by the United Nations Brutal Commission. They told that sustainable development is the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. That is, we should preserve the earth and we should hand over to it our generations to come. We should leave something for them so that they can enjoy the earth how we enjoy. So basically, from an industrial point of view, we are looking at 3 points mainly. One is economic performance, the other one is environmental performance, the other one is social performance. When our organization is able to maintain this economic, environment, and social, all these 3 things in a equal balanced level, I underline the word balanced. When we are able to maintain a balanced level of environment, economic, and social, otherwise we call it as the 3P model, that is people, planet, and profit, in an equal balanced level, then we call that development as sustainable development. That activity or the manufacturing process, what we are going to do is called a sustainable manufacturing. That is, when we manufacture a product, it should not affect the environment, it should be economically profitable, and it should not affect the people in and around. Okay, we have a lot of cases. We have experienced 2-3 years before, we experienced the worst cases, what happened in Tamil Nadu when it comes to society, environment, and economic. I'm not going to point out the name of the industry, but we all know which industry I'm talking about. Okay, so it's a subset of all the 3 things, environment, economic, and society. So this is where all these 3 things are going to coexist in a balanced way. So that point, this blue color point, we are going to call it as sustainability. So that's the definition of sustainability, and we know why we need it. Okay, so next, again, the other part of the world, where all world nations have agreed to achieve this 17 sustainability goals. As before the lecture started, our Selvaraj sir has rightly pointed out that why it is required to address this 17 goals: poverty, zero health, good health and well-being, quality education, gender equality, clean and clean water and sanitation, affordable and clean energy, decent work and economic growth, industry innovation infrastructure, reduce inequality, sustainable cities and communities, responsible consumption and production, climate action, life below water, life on land, peace, justice and strong institutions, partnerships for goals. I have spelled out, I read out all the 17 goals. Now I'm leaving it to you to judge as an engineer, as a industrial people working in industry, which goals we can be achieved, or directly or indirectly to which goals we can contribute. Okay. Can you think? I'm giving you 2-3 seconds for you to think about to which of these 17 goals we can contribute directly. Okay. We will be contributing majorly to these three, irrespective of our domain, or like mechanical or industrial or civil or chemical. We will be contributing to these three sustainable development goals. That is industry, innovation, infrastructure, sustainable cities and communities, responsible consumption, production. As most of us from BHL or from any of the part, we are all going to focus on responsible consumption and production. That is SDG, we call it as SDG number 12. That is Sustainable Development Goal number 12. That is called as responsible consumption and production. Okay, so this is what we are going to discuss for today, and how technology, disruptive technologies are going to help us in this to achieve this SDG goal number 12. That is responsible consumption and production. Now, before entering into that, I like to give you, for people who are not aware of this sustainable or product life cycle, I want to give this one particular slide for us. So we all know how from raw material, the product is manufactured and how it is going to dispose. Okay, often the raw materials are being, the extraction process will happen to mine, to get the minerals or the ores from the earth. There we are going to use energy, and there will be some carbon emission out of that. Then it will be transported and it will be converted as raw materials. In case of BHL, we are going to have a lot of tubes, pipes for building boilers and other ancillaries. Then in that process also, we are going to use energy and release carbon dioxide. Again, it is going to be transported to the production area, say for example BHL, where the production of boilers is going to happen. Again, energy and carbon dioxide is going to be consumed, carbon dioxide is going to be emitted. Again, it transported to the area where it is going to be installed and used for power generation or for other purposes. Then again, it will be transported. Again, when using the boiler, again energy is consumed, or carbon dioxide is emitted. Same way, it's going to be again transported, and after end of life, the boiler, the boiler, after the useful service period, it is going to be disposed. We call it end of life disposal. Even in end of life disposal, some products consume energy and release carbon dioxide. Okay, so that's from upstream to downstream. What we discuss is from upstream to downstream. Any product will have this product life cycle. Okay, now this everyone will know, but what I'm going to discuss about next. So from extraction, if I'm talking about extraction till the product goes out of the gate of the company, from extraction to the gate of the company, if I'm talking about their particular product, then that is called as cradle to gate. That is from the birth of the material to the gate of the company. So that we call as cradle to gate. Next, if I start from extraction of the product to the end of life disposal of the product, that is a linear supply chain or the linear product life cycle model, straight from extraction to end of life. If I'm going to discuss about a product or consider what are the energy consumption and what is the carbon dioxide emitted in this, if I'm going to talk about that, then I call that as cradle to grave. That is from birth to death, like a human life cycle. Next, if I'm talking about from extraction to end of life, again to upstream, that is extraction. I mean, like if you're trying to keep it in a loop or a closed loop structure, then I call it as cradle to cradle. Okay, so now you can easily understand cradle to gate, cradle to grave, and cradle to cradle. So these are the three synonyms which you will be keep on listening to this when we discuss about this sustainable manufacturing. So always, now to achieve this sustainable goal number 12, that is responsible consumption and production, we should always try to design, manufacture, use, and dispose properly to achieve this cradle to cradle. When you're able to achieve this cradle to cradle, that is closed loop structure, then we are successful. Okay, then we can achieve sustainability easily. But how to do that? Okay, in this process, the transportation, energy consumption, carbon dioxide emission, these all result in what? we call it as eco footprint, or if I consider only the carbon dioxide, then I call it as carbon footprint. If I consider all the gray water that is discharged in all these processes, then that is called as gray water footprint. So like this, for each and every emission, we can map it, and we can understand why this is getting very important. Then what does sustainable manufacturing in practice, like again, these are some basic slides which I want to cover for people who are not aware of this. So we always should try to use materials that do not deplete the natural environment. That is eco-friendly materials. Selection of materials should be eco-friendly. Next, we use less material, and that material should not be hazardous to the environment, and it should be recyclable. So as a design engineer, we take a role in this. Next, when you manufacture that, don't use always try to use less energy, less water, less material, and your manufacturing process should not produce more waste. It should be less waste. Next, while packing and delivering the products, use efficient transportation and logistics methodologies, so that don't use over packaging. Always go for sustainable packaging. Plan your transportation logistics effectively, so that you don't leave a lot of carbon footprint for your transportation logistics, especially for third mile delivery. Then you work with your stakeholders and customers, and even in your sales and distribution process, we should always focus on maintaining a we should keep our level. I mean, the sales volume should be high, but for the distribution, that is the third mile delivery, should not create more. Next, so in the use phase, when you're using the product, you should allow it for when you're designing the product. As a design engineer, we should be able to make it easy to repair. Previously, when the mobile phone will not work, as a simple, even though we are engineers, we know that if we switch on the mobile or remove the battery and put it, that will work. That was talking about when Nokia was there, right? So nowadays, everything is becoming the battery is becoming an embodied product of the cell phone. We are not able to do that. I mean, like restart was the option, but nowadays even we are not able to restart by removing the battery. So making it complicated. Again, whenever we are trying to use the product, considering the end of the life, the design engineer should make the product reusable, remanufacturable, recyclable, and biodegradable. So all these things, if we are able to do at each and every stage, if you could observe, I just talked about from raw material extraction to the end of life disposal. At every stage of the product life cycle, if I'm able to do some justice to make it eco-friendly or sustainable in nature, then that practice is called as sustainable manufacturing. And if you are able to contribute to any of this, then SDG is easy to SDG number 12 can be easily attained. Okay, so now how to achieve this or how to implement this sustainable manufacturing? Sir, I'm having a very small tea shop. I won't be able to. I'm not having a big corporate to take care of, to invest more. Okay, we have solutions for each and everything. You can start from easier one, like start from housekeeping. When you do a lot of simple housekeeping, think about all our lean concepts or lean concepts. When you do all these things, what happens? If a simple fires can help. A simple fires will make all the wastages in your company easily visible. Safety will become priority. So just by doing some simple things, you can achieve sustainable manufacturing in your level. I mean, depending upon the organizational level. Next, process optimization. That is making adjustments to process to increase efficiency. Like I'm doing some process, say for example, I'm doing an injection molding process for a bigger component. Okay, it's going to consume more energy and more material. Material wastages will be there to trim down on other things. So instead of injection molding process for a bigger component, I can go for vacuum forming technology, where I can just put a plastic sheet, heat a male dye and female dye, and using vacuum, it can take the shape of the female dye, and you can get the product. So this we actually did for some mini plastics. Now it's called as Reva cars are that in that company we did a project related to process optimization. Then substitution of raw materials. How to substitute our raw material? Like say for example, I'm going to manufacture a product by using a more non-eco-friendly material. materials. Let's say, for example, the fan blades, I mean, a simple table fan blades. Instead of making it with steel, I can go for some other plastics. I know plastics are also not eco-friendly, but still compared to the manufacturing, the carbon emissions and energy consumption in manufacturing a fan blade or some component for that matter, a replacement. If I manufacture the same component by another raw material, it's going to be environment friendly. If it is there, it's okay. But don't tell me that instead of manufacturing instead of producing a chair by using plastic, I'm going to make the chair by using by wood, because wood means you're going to cut down a tree. So that is not again eco-friendly. So, but wood is biodegradable, is safe to environment, everything is there. But I have to cut a tree. So cutting a tree to make a chair is not advisable. So raw material substitution has both advantages and disadvantages. We should be very careful while selecting the material. Then adopt new technologies, like some technology, like you can go for renewable energy technologies or some kind of alternate energy resources, or even sometimes the processes, the way you make them. Say for example, we are going to have a CNC. Of course, the cost of investment is going to be high, but over a period of time, the return on investment is going to be very huge. So we can go for investing in new technologies rather than going with traditional ones to reduce the energy consumption or waste generated, etc. Next, how can we make the product sustainable? Again, we can make a change in design. Like you can, by changing the design, you can reduce the amount of material consumption, or the time spent on manufacturing the product, or the energy spent on manufacturing the product. Like nowadays we have topology optimization, generative designs in 3D printing, where you can reduce, you're going to provide material only where it is required, not in all parts. That's why we are able to get lightweight aircrafts, lightweight cars, everything. So product design in the other way. So whereas, as I told you, this housekeeping is easy, but whereas as you move on towards your left to right, it's going to be get more difficult or more complicated. Okay, I'm just giving the fundamentals of the sustainable manufacturing here. Okay, next tool what we have is called as life cycle analysis. When you know this life cycle analysis, it's also called as eco balance analysis or cradle to grave analysis. That's why I was giving the explanations for cradle to gate, cradle to grave. Okay, so this analysis, life cycle analysis, you can do in any level. It has this LCF framework is shown towards your left hand side, where it has a goal and definition. Like we have to define the boundary conditions, what we are going to study, what are the essential things we are going to consider. That has to be first defined well. Then we are going to conduct a life cycle inventory assessment, like what are the inventory involved in it, what is the energy input, energy output, what forms of energy is going in, what form of energy is going out, how much is the consumption, material flow analysis. Everything comes under this life cycle inventory assessment. The next part is impact assessment, like what is the impact done or damage done to the global warming potential, water eutrophication, energy consumption, air acidification. So like this, we are going to split it out. Okay, then in interpretation part, I'm going to give you some list of data on what materials alternate materials I can choose. What is the sourcing instead of if procurement, or instead of procuring from here, if I can procure from other place, what is that? What is it? How can I change the design? But the policy making strategies and others can be easily understood from this life cycle analysis. So this is going to be we can call input analysis also, like the input output analysis. What I'm going to give input, you're going to give the input as raw material or the energy. It is going to be get processed, the raw material acquisition, manufacturing, operation, maintenance, usage, recycle, waste, all these things are there. But what is going to be released ultimately? Any product can be converted into any raw material is going to be converted into a finished product or a semi-finished product. But in this process, what is going to be emitted out to the atmosphere, to the water, or is going to end up as solid waste. So we are going to define this system boundary. This is what I'm calling about system. This is the boundary within which I'm going to conduct. Because if you take the life cycle analysis, you can't predict what you did from the time of your birth to the time you go to the grave. It's not possible. Same way for any product, when you're going to manufacture, to do the life cycle analysis, it's very hard for us to predict or to compute this raw material consumed, energy consumed, what is released to out by the particular process. So it's very data oriented process. The good quality of data what you use for life cycle analysis determines the output of this. We have a lot of softwares like Gabi, EcoInvent, like that for SimmaPro for doing this life cycle analysis. Okay, the next important topic which we have to understand is called as remanufacturing. People normally call it as 6R approach. This 6R approach is what we can recycle, repair, renovate, recondition, recycle, and remanufacture. Reuse, we know you can, if you can refix your bulb and use it for a table lamp, you can use it. You can repair your cycle and reuse it. You can renovate your house and use it. You can recondition your bicycle or the tires, retrading, that can be done. Or you can completely shred your tire and make it as a road pavement, recycling, manufacturing, remanufacturing. So you all know that previously the Apple mobile phones which were sold in India are not the original ones. Shocking, right? Yes. If you could still see any old Apple showrooms, they may have the board, their hoardings like a refurbished mobile reseller. That is, they procure the mobile from the used mobiles, they make it as a new product and they are selling it. Even in our online portals like Flipkart, Amazon, they have this refurbished products. What is that refurbished product? They will look, they'll perform, they will be exactly mimicking the new product. There won't be any different. You can't find any difference between the new one and the refurbished one. That is a remanufactured one. If it will be looking similar in performance, in efficiency, everything it is same. But if you're able to do such a product, then that activity is called as remanufacturing. Okay, so what is the advantages of remanufacturing? If you're able to put the product back into the loop, then what happens? You can stop consuming extra material. Say for example, as a BHL, if we are able to give the rebuild our the used boilers, the demand for boilers may come down. I accept that. The demand for new technology, new boilers can come down, but still, this refurbished or the remanufactured boilers can be installed in some places of or where people have no access, or if it's of some usage can be altered. The usage can be altered for the low level applications. We can even still think about using those boilers. Okay, so to understand more about this remanufacturing, we have this Ellen MacArthur Foundation. They came out with the butterfly diagram. I'm just giving you one wing of this butterfly diagram where it insists on repair, reuse, remanufacturing, and recycling. So recycling should be the last option. It's not like that I consume a water bottle of water, I throw it out, it gets recycled. No, recycling should be the last option. We can try to reuse the water bottle. We can shred it and we can try to manufacture some other product, or finally we can go for some other recycling methods if they are available. So that's what. So remanufacturing is also very important. Okay, now we know what is sustainability, how sustainability can be implemented, what is product life cycle, what is life cycle analysis, what is remanufacturing. Now we know very well about the sustainability, the importance of sustainability, how we can achieve sustainability. How in product, in process, by changing the material, by changing the process, by changing the design of the product, how we can achieve sustainability, even we know that now. But what are the industrial challenges? On the other, this is somewhere about environment, product, everything. But on the other hand, the industrial scenario is different, correct? First, what are the core problems? Let's look into some of the industrial core problems. First is shortage of labor. We experienced this very well during this first lockdown itself. During this pandemic first lockdown, we experienced, like, many people started to leave their job and they moved to from one part of the India to another part of the India. They started walking, which we could never imagine. We know that. So that happened because of labor short, and we met many organizations, many small scale and SMEs and MSMEs. They met, they even some hotels. They didn't have enough labor to support the process. Then, if you observed, this KPMG survey is telling that more than half of the project, that is the project, has failed because of this pandemic and other things. Okay, compared to previous years, there is a drop in the project performance. When you take environmental sustainability, around 25 to 40% of the carbon emissions are emitted by the core industries. Okay, then there's a shrinkage in profit margin because of a disruption in the supply chain management, supply chains. That you know that only one vessel blocked the Suez Canal, the supply chain got disturbed for more than two months. There's a shortage of drivers in Canada and US. They didn't celebrate the New Year and Christmas very well. Still, there is a shortage of drivers in Canada and US. Next, rise in spend. If you see the overall, we see that the rise in spend, like the money spent on industries have increased. You could see the defense is only 47%, whereas our sector, that is manufacturing, it's around 55. Due to COVID, the pharmaceuticals saw a huge rise, and semiconductors faced due to disruption supply chain. Even the semiconductor industries are booming up with 56%, and pharmaceuticals with 56%. But next comes our manufacturing, 55. Okay, this is based on the CAPS report. What are this coming to convey to us? So, what are the core? I mean, what are the objectives of any industries in post-pandemic time? We are always focusing on-time delivery. How to do on-time delivery? By collaborative, by dynamic and adaptive real-time resource mobilization is required. Okay, on-time delivery of projects is failing. We are not able to deliver our supercritical boilers on time. We are not able to deliver the constructed houses on time, right? So everywhere there's a stagnant is happening. On-time delivery of projects which we got already we are not able to do it. Next comes real-time and accurate progress. What is the exact situation where we are lagging? What is our consumption pattern? Whether we are delivering it directly from the sources, whether the process are clearing with minimal reconciliations, we are not able to track. There is a lag in information sharing and tracking. So that is also one drawback which industries are facing. Then optimal planning and utilization of resources. So already the resources are, sometimes we see many industries, what they do is they have a lot of resources, but they don't know where the resources currently now, especially like government projects. They don't know there will be multiple resources. So, and they don't, if any resources planning, they go for buying the new one. So optimal planning and utilization of resources is also one of the objectives of industries in this pandemic situation. So how to achieve these objectives? By managing all these things: customer delivery management, work plan management, resource requirement planning, earned value management, cost management, performance management, contract management, scope management, productivity management, at last reconciliations and consolidations. How these things will happen? How organization can have a control on all these 12 domains or 12 risks involved in this pandemic situation. So there comes handy all our disruptive technologies. The recent modern contemporary technologies are going to help us in this. What is this disruptive technologies? We never know that we are going to use Uber. I never know I'm going to stay in Airbnb when I go to abroad countries. I never know I'm going to share a taxi with with others. Next, I never know I will take photographs only through my mobiles, not even DSLR cameras. Kodak, only our generation knows what is Kodak, right? Next, we started hearing tunes in gramophone, tape recorder, almost like CDs, DVDs, mobile phones. Now cloud, iTunes, Ghana, like this. We have a lot of apps for listening the songs, right? So change is mandatory, change is required. If we are not changing, ultimately we are going to lose. One good example: Nokia was hesitant towards changing towards Android. It wanted to develop its own app, a mobile OS, but it failed. So Samsung Samsung started ruling the market. Nokia was completely a loss. If in 2002 or 2004, if someone was told that Nokia will not be there in the market after 10 years, I could have not believed. But it happened because change is required, and they were not ready to make the change. So we have to move to that we have to adopt this digital disruptions, whatever is happening. Then there comes this concept called as IoT, that is Internet of Things. Okay, Internet of Things means I mean Industry 4.0. They are part of this. The investment of why I'm talking about on this is because we could see that from the Business Insider Intelligence Survey, we came to know that in manufacturing industry, especially in manufacturing industry, started investing more on IoT solutions. It is rising year by year. This is a very old survey. This is only for up to 2019. If you take the recent survey, especially in this pandemic situation, the investment on manufacturing on IoT solutions has increased a lot. Okay, so what about the facts? How much it has increased? 45 billion devices are going to be connected before 2025. I think we have crossed this already. 11 trillion investment is happening by 2025. McKinsey says this. Also, McKinsey says that $260 billion of investment is going to happen in IoT systems. So if you could see, there are a lot of investments that is happening in IoT. And IoT has also opened a new business markets, business models. Preventive maintenance, predictive, prescriptive. Before the mistake happens, before the failure is going to happen, the maintenance department will be alerted and they're going to attend it. Consumption model has changed as a service. Then business analytics, real-time analytics, big data analytics, all these things are picked up. Service-oriented, self-service, self-guided service, drones, etc., etc. Third mile delivery has been exceptional, especially in delivering of this COVID vaccinations in rural parts of South Africa, everywhere. So IoT is paving everything. But what is this IoT I'm talking about? It's all manual today. It was manual yesterday, correct? But what was this? All these IoT devices new to us? No, we are already a truck fitted with RFID tag. We have forklifters having all this thing. We have sensors, we have cameras, we have human machine interfaces. Everything was there already. All these IoT devices are existent or were existing. And on the other side, you have business applications, manufacturing, supply chain, asset management, all these 12 things, what I talked about, all these things are there: vehicle, vertical apps, utilities, healthcare, retail, sales, management, customer relationship, SRM, CRM, everything is already there. But how it is happening today? In the current process, everything is there, all the data are there. Manually, we are entering. If anything happens, we have a reactive control mechanism. Only when the mistake happens, we react. Okay, for that particular day, and we finish the issue, we close the issue, we get it listed in our KPI. Done. Okay, so how this is going to change? How this has changed for tomorrow? Already these IoT devices are there. This IoT devices we are going to connect using in the this connect to the business applications. By what? By using an IoT platform. These platforms are going to connect, analyze, integrate, and act for the solutions. So this is what we are going to do. This is we are going to marry IoT devices with the business applications. We are going to connect, interconnect, and let it do the process automatically. Okay. Next, if you ask me, what are the 9 technological niche areas, 9 niche technological areas in Industry 4.0, or autonomous robots, horizontal and vertical integrations, augmented reality, additive manufacturing, the cloud manufacturing, simulation of the digital twins, big data analytics, industrial IoT, cyber security. So all these 9 technologies are going to rule the world. I'm not going to go deep into this each and every technologies because most of you must have already been using these technologies. Any 1 or 2 you must be already using. I'm going to explain through some 11-12 case studies I'm going to discuss with you. So how a smart factory looks, it's going to have some robots, cloud computing services are available, big data technologies are there to store all the data and retrieve the data whenever it is necessary to take important key decisions. You have embedded systems for control and monitoring. If anything goes wrong, immediately the information goes to the maintenance department or the concerned supervisor. He attends it. Then wireless communication is happening everywhere. You go to your home, something wrong goes in your electroplating division, or something goes wrong in your CNC machine. Immediately the information comes to the supervisor who is sleeping in his home, and immediately he can rush to the spot and he can address. He can clear that. Okay, at least for the next shift, he can plan. If there is any shortage of raw materials, it's going to happen. So smart storages are available. Flexible and intelligent logic systems are there. What is flexible logistics and intelligent logic systems? You are having a printer. Today is 25th. Today by night, your printer is the ink cartridge in your printer is going to go off. There is you can't print any more pages. Tomorrow is holiday. 27th morning, you have to again come back to your office. Today, by 25th night, 8 o'clock, the message will go to the particular printer cartridge company. That cartridge company will release will inform the retailer in the particular place. Say for example, in Tiruchirappalli, Belnagar, there is a supplier. So he gets information. So he gets ready with 27th morning. He will be ready with your printer cartridge, and it will be delivered to your office. on 27th morning when you open the office, the cartridge will be available for you to print. So these things will not happen. These things just you will get information. Your printer is added, printer is ordered, purchase order has been released. You make the voucher ready and keep the payment ready for paying the retailer who is going to come on 27th morning. So this, like this, all systems are integrated, or they can take their own decisions, right? So artificial intelligence or machine learning, all these things are going to help us with this smart factories and IoT environment. Okay, in your project, now let's go back to our own companies. You can compare your organizations with this. So normally we do a work plan. We do the, I mean, how is the traditional approach happening? First, a plan is developed. The resource requirement will be done. I mean, all the resources will be made available according to the work plan. For every time you have to wait for the approval. For every time you have to approve for the validation and approval. Then the procurement process will happen. You will have some tenders and negotiations will happen. Then you will have the receipts. Then you will do the progress entry. Then if anything has to be changed or any reconciliations will happen, then you will meet the customer commitments by meeting out their margins. So if you see this, everywhere there will be some bottlenecks happening here. There will be a bottleneck happening here at all these places. You have to wait for the approval for everyone. That's how a traditional approach will happen. But when you do this IoT applications, what happens? Everything is interconnected. So we can call this as across the wall approach, right? So everyone can communicate with everyone. So as soon as the work plan is ready, it will be sent to the resource procurement team, purchase team, resource mobilization will happen, project procurement process will happen on the parallelly. Task managers will be informed. They'll keep on updating the progress, the measures and metrics, like how the performance can be measured, and invoice will happen automatically. Contracts are going to, tenders and contracts are going to happen automatically. Costing will be done by the software by itself. So everything is going to be automated if you're going to adopt IoT. Okay, just this is for your example. Okay, how a project conducted by using IoT will be. Imagine there's a road construction is happening, and if due to some bad weather or some temperature fluctuations in temperature, sometimes there may be a shortage of this cement bags or something can happen. Okay, so or one of your road roller can fail. So when all these things are fitted with some sensors or what do you call this sensing devices, if any abnormal pattern is being noted in case of inventory or in case of the equipment, and because of which the project can delay, the planning manager can sit in the project office or the project supervisor who is located in a remote location, or the task manager who is further away from the project office. They can easily come to know what is happening in the field, in the construction site, and they can take some useful actions. So thanks to this IoT devices, connected IoT devices. Okay, so what is achieved when you do this? Reliability is there, because every time real-time data you're able to get. The data are real-time. You're able to reach your team. You're able to connect with your team members at any point of time. So when you do this, automatically you get very good alignment, agility, and accountability for the project or for the manufacturing process, what we are going to deal with. So that is what is achieved when you use IoT. Next thing is resource planning and utilization. The next objective of any industry is to achieve resource planning and utilization. I'll give you some examples. So what IoT can help? It is going to tell where your equipment is located. Maybe you may be like an L&T like company or BHL. It is located in many places across India. You don't know which resources available at which place. So it will tell you which resources is available. You need a crane. It is located there in Ranipet. If you need that, you can pull it to your Tiruchirappalli center. I like that. Then you know what is the consumption pattern. How much material is required. How much is consumed. Like a lot of times I have seen personally myself that you could see a lot of raw materials lying in the yards of BHL Tiruchirappalli campus, right? A lot of resources are there, but we don't know which resource was procured when and where it is going to be used. Sometimes, I mean, it's my own assumption. Maybe you may have the idea, but some monitoring mechanism will be available. What is to know where is the resources available, how it can be used, how long it can be used. Then our progress level can be maintained. If anything is required from the past performance, we can compare and we can take some important key decisions based upon our past performance also. This is what IoT can do. But when all the devices are connected to IoT. One good example. Okay, say for example, I have to travel from one place to another place. You have a truck driver who is going to deliver one raw material. Say, for example, from BHL Trichy to Ranipet, there is some consignment which has to be transported. That they can travel through Viluppuram, then they can come to Tiruvannamalai, and then they can come to Vellur and reach Ranipet. That is one easy way. There are multiple routes, but let's imagine this one route. But sometimes what happens, the truck driver has a sister's house on the way, some 40 kilometers away from Tiruvannamalai. So what this truck driver will do, he'll go to his sister's house, stay for one day, and next day he will after 48 hours he will reach the Ranipet campus of BHL. What is going to happen now? The consignment is very key, important consignment, and you are not able to. He has switched off his mobile phone. You are not able to track him. What you can do, if you can fit a geo sensors or GPS technology, if your truck is going to have a GPS technology, you will know this vehicle has started here at this time. You can trace the path of the way in which it is traveling. If it is deviating from the travel path in which it has to, and if any deviation is there, you can ask him, you can immediately call, or you can trace him through some other mechanism, and you can insist him that this consignment is very important. Please deliver it by tomorrow morning at the Ranipet unit of BHL. So that can be done. So this is this geo fencing, that is, you can mark the fencing. Like if any deviations from if your vehicle is moving away from this deviation, you will come to know, and immediately you can catch hold of that particular consignment and you can make it reach correctly. So this geofencing is a tracking mechanism. This is one application of IoT which we can use. So it creates and tracks virtual boundaries. Like in the map, we can draw the Google map, we can draw and you can trace it. Then equipment management, you may know, like this, whenever we ride, we have this forklifters or any movers, trucks inside the factory. If they can move fastly, you can even monitor the progress of this forklifter. If there's a speed sensor installed in that, you will know what is the efficiency of this, how much he is driving, what is the speed limit of this driver, how he is handling this vehicle. Everything you can get. So by this, you can do equipment management. Then what are the benefits of this? You are going to improve your cost. You are going to reduce increase accountability and reduce wastages. Processes can be optimized, and procurement decisions can be taken very easy. Then what is predictive monitoring? How is going to help here? Okay, so this prediction with fields, right? So prediction is about forecasting. So if you're able to forecast well or predict well in advance the failure of some equipment or the delivery of some raw materials, then you can use then there comes this prediction with field inputs, the real-time data accuracy. If your accuracy of your forecast is good, then it will be easy for us to maintain the process flow smooth without any bottlenecks. So this is what happens, right? In prediction with fields, like the task manager will be submitting the reports to the IoT connected devices, and he will know if there is, say for example, if there is a construction activity for tomorrow has to start, and it's still now the raw materials essential for the say for example the cement bags have not arrived in the particular consignment. So if it's a normal system, what you have to do, you have to go to the project manager. The task manager will be going to the project manager office. He will asking for extra budget. Okay, tomorrow 10 o'clock, 8 o'clock, the construction activity is stopped, but if it is already 10 o'clock, your raw material has not reached, then you have to run to your project manager asking for extra for alternates or something like that. Then this project manager has to run to the finance manager for asking for approval and everything. But rather, if it could be an IoT system, what can happen is this task manager can surpass this project manager and give inform the finance manager to sanction the budget immediately, and he can go for buying the cement bags for the particular day, and you can start the construction. Because of cement bags, if the construction is stopping, then the company would meet with lot of loss, huge loss, because they have to pay for the labor, the movers, etc. So that's what it can increase the accuracy. If you can predict by using this IoT, the forecast is going to be high, on-time delivery is possible, cost on overruns can minimize the cost of overruns. Then any deviations is there, you can for accountability will be there. So what is the raw material consumed, what is the raw material available, so all this accountability will be there with us. Then change adoption. So change adoption is not an easy task. Just to change one particular dimension in your design or in a drawing what you made will be there is a lot of change management that is required. Okay, let's take the same example. We have a task manager. He is getting a lot of inputs. Then he is requesting, the client has requested for some change. Okay, and it goes to go with a planning manager who will give some other way. The project manager needs to consider all the inputs of task manager, client, and the planning manager, and it will be confusing process for them to take the decision. So it's always the game between the money, time, and value, because time is money, money is value, value is money, money is time. Everything is interlinked. It's a three-sided graph. Okay, three-axis graph. So whichever is there, the other one is going to be affected easy. So rather, if each and everyone is communicating in a different way, different pattern, it is highly confusing. Rather, if there is a dashboard or if there is a virtual collaboration that is between them, then it is easy for them to understand the scope of change, or it will be easy for them to understand what is required, why they are asking for this change, and whether this change can be accepted or not. All these things can be considered. So this is one inbuilt change adoption mechanism. So if that is there, automatically instead of going to the project manager, the project manager can readily can consider the request from the client. What is the proposed change? Then they can discuss with the task manager. Then once the client approves, okay, you want to make this change, okay, I agree. If it is costing extra also, no problem, I will pay for that. If the client is giving that authority to the project manager, immediately the approval change, the change in approval can be passed, and the change management will happen. The scope can be altered by interacting with the customers directly. Okay, then predictive monitoring alternate. Say for example, just as I told you, that's this is, imagine this is Tripoli and this is Ranipet, because we have Pala River and some rivers are there. Okay, so imagine that there's a crane which is there in Ranipet. It's used daily, but it is predicted that using some predictive mechanism, we predict that the next 4 days this crane is going to fail. This crane will go under repair in next 4 days. So what now they can do is they can immediately call to the other facility in Trichy, and they can ask this crane. There is an extra crane over here, so this extra crane can be moved to Ranipet division in the next 4 days if there is a predictive mechanism which is properly working. So like that, this can be done with if you have predictive monitoring system for the cranes installed in Ranipet. But if you are going for a new crane, it may cost so much dollars. There will be delay in 10 days. The throughput of 500 tons per day cannot be achieved. There will be huge loss, or the systems can completely stop in the other unit if the cranes are not available. So rather to face this difficulty, this crane which is available in the other location can be moved here. Okay, so that is one best way. So it can, if the change is there, then risk adoption, it can mitigate the risk. The risk margin can be reduced, the accuracy can be increased, and the scope of the project will be there. Then delays can be avoided. So these are the inbuilt change adoptions. And again, blockchain technology is there, where you can have smart contracts or smart applications are there, which will help the owners, operator, and the system suppliers to go for some agreement using the smart contracts, and they can achieve this through blockchain technology. Then let's go with some use cases. I understand I have a time constraint now, so let me go with some use cases very quickly. Okay, the first use case is a leading pump manufacturer who is manufacturing submersible pumps, centrifugal pumps, and circulatory pumps. And they also develop some electronics for the control system of their pumps, and they are ready to adopt these new technologies in their pumps. Okay, say for example, this is what. So how these pumps can be integrated with Industry 4.0 technologies or IoT devices. So we know this. There are normal valves, pipes, drivers, and tanks. They are fitted with some level sensor, temperature sensor, and chart controller. And this is level 0 and level 1. In the next level, they can be monitored by using a human machine interface, a PCS, and a PLC. And again, this can be connected to the APS, MES, and quality management systems through some mobile applications. On a larger scale, again, they can be connected to the ERP, CRP, MLM. So whatever, if anything, any of this valve is not functioning, then immediately through the level sensor, it will go to the PLC or the HMI. This will again be intimated to the concerned supervisor or the in charge through this APS EMS or QMS systems, which will be already also recorded in the CRP, ERP, and PLM systems. Okay, this valve has gone. Again, the ERP system will inform the purchase department, and they will take the action to replace this valve, and there will be information sent to that CRM, that is customer relationship management, that there will be delay, and another, it will be also through some hand-on systems, it can be informed to the purchase department, the maintenance department, for them to address the issue with the valves. So like this, the integration, connection, implementation. So this, what you're seeing, is called as a vertical integration. Sometimes integrations can be horizontal also. So there's always a horizontal and vertical integration that is happening in parallel. We call that as cyber physical systems. Okay, that means like that's what I told. So the systems are driving PLC, HMI, SCADA are taking control with what? With the physical, with the real-time items like pumps, valves, sensors, machines, and robots. So they are taking the advantage. Also in logistics, production, distribution, they are of greater importance. The use case too, it's about the automobile spare parts industry. The manufacturer is high tech savvy, and they're connected with everyone in the company. They manufacture products like electronic systems, powertrain, and suspension systems. Okay, there is a vehicle which is traveling from Chennai to Trichy. And what happens is that after crossing that place called as Viluppuram somewhere, or say like Perambalur, say the vehicle has started after reaching Viluppuram. There is some damage in the transmission system. Something went wrong in the brake failure. Let's say this example I given as brake failure. So there's a brake failure that has happened in Attain, but the vehicle is movable, not much damage will happen. So before the vehicle reaches Perambalur, from Viluppuram to Perambalur, what they can do, this will be informed to the central facility, and this central, as soon as the vehicle reaches this Perambalur, the Perambalur supplier will be ready with the Perambalur dealer will be ready with a new brake system, and as soon as that is there, he will be having along with the sub dealer will also bring with him the mechanic to repair replace the brake pad in that particular vehicle, and and it can be saved. Major actions can be saved. So this is, and because the consignment is also important, you can't stop the vehicle at Viluppuram and do the maintenance activity. In the middle of the road. So this spare part company is the business. If it's a real system, if it's if it's not connected with IoT, or if it's not there into the connections, what is going to happen? The vehicle has to wait till the order goes to the particular supplier in Perambalur. The Perambalur driver has to drive to thing. And I mean, it's not going to happen online, like on the way. It has to stop. It has to do the active brake pad repair. Then it has to travel. So there's a lot of constraints in doing this. But whereas IoT makes it very simple. Again, in shop floor, this is a use case number 3. Shop floor, we have this virtual reality and other things, which is going to tell you the real-time data. If anything is going to fail, it will tell. Okay, let's take the example of a lathe. What is the turning speed for any tool replacement? A single point cutting tool, for example. If you're using, what is the depth of cut? What is the speed? You have to maintain everything. The tool wear monitoring mechanism can be there. And if you have this virtual or reality or augmented reality approaches, it will tell you the system is there, the system is failing. Just if you put your mobile phone or your pad on that, it is going to tell which part is not functioning properly. All these things there. Then accurate. I mean, overall, the big, say for example, the whole of let's consider whole of BHL, which is of more than 5,000 acres, 5,000. 5 acres, 50 acres maybe. So we don't know where the mistake is happening, right? As the entire plant put together. So this IoT will tell you, okay, this particular point, this particular bay, in this particular booth, the machine is not working properly. So for failure and maintenance, this is of very, very useful. Then when it comes to warehouse applications, imagine we on the Trichy road, we have this Reliance Mart. The Trichy Tanjavur High Road, we have a Reliance Mart. It's very difficult for us every time to go and check what is available at or say a shopping complex like Walmart. It's very difficult for us to go and identify. Rather, if you scan something, and if you have a scanner or if you have a Google Glass with you, it will become very easy for you to, it will drive you, or it will take you, when you wear that Google Glass, it is going to, through through augmented reality, it is going to take you there, and you're going to, you can easily locate your product. Mostly, like I make mistakes when I buy grocery for my house. I'm always confused with this dur dal, moong dal, and all these things. But it will be easy if I know if I wear this dress, it will easily tell me where is moong dal, where is tur dal, and other things. So it's very easy for me to identify things. Same way, it's applicable in warehouse operations also. What is doing actually? It's going to build, it's going to fix, it's going to move, it's going to operate, it's going to make the work of the worker or the particular man in the warehouse very easy. The use case number 6, we have automotive services company. What this company is doing, this is just an app. This is already available. This is a dashboard which understands. This is for an insurance automotive service insurance system, where it is going to tell you how much distance you are going to travel, what is your badges you are earned, what is your community, what is your safety rating, what is your education, all your profile data. It's going to tell how much kilometers you are driving smoothly, what is your mobile distraction, what time of the day you are driving, how much your fatigue level, and what is your speed, how much kilometers you have driven in the last 120 days. So all these things are available. This is just a dashboard which I got it from my friend in US. So what they are doing, this insurance agency, for example, I'm going to drive from Chennai to Bangalore. The route is already defined. It is going to tell me how much kilometers I have driven, how much distance I have traveled, through which route I have traveled, and it predicts my journey details. Like overall, when I travel from Bangalore to Chennai, my fatigue level was 84. 95 times I was distracted by my mobiles. Then 95% of time score I got for smooth driving. In daytime, what time of days? During the daytime, I drove the vehicle for 76 hours. 87 was my average speed. So depending upon this, I get some batches, and these batches are going to tell me how much insurance I have to pay. If my driving is smooth, if I'm driving only in the daytime, if I'm not driving at the night time, and I'm not distracted by mobiles, if my driving score is more, I get my insurance based upon that. This is already in practice. Imagine if this comes to India, maybe our insurance are going to be a very big question mark. Okay. Next case is with Buick. Is already, this Buick is already famous in China. They have sold many vehicles in there. Almost every house has one Buick vehicle. Almost everyone is having this Buick car. So there again, the same thing is there. How much? What is the monthly score? They are also calculating your. There's a smart drive app. Almost now this is available with all vehicles, even with Maruti or Hyundai. Everyone is there. How much? What is your hard acceleration point? How much percentage of night driving you did? What is the distance travel? What is the fuel economy? Average speed? Everything is being calculated. So this is already available. The Buick Smart Driver. Now this is available with almost all cars in India also. So it predicts how much mileages you have died, what is your oil life left, what is your tire pressure, everything is monitored. Your emission control systems, your airbag systems are in function or not, just like a cockpit of your aircraft. The cockpit of the aircraft will have all details measured through sensors. What is the air pressure and what is the fuel level in the tank? What is the pressure everywhere? It is going to tell you, right? Same way, this Buick records all this, gives all these records to the user, so that the user can plan when to give for maintenance, whether the maintenance time is there. It's really like a vehicle monitoring system. The next is like, imagine Next Power Gen. I have just given them my own name, like Next Power Gen Limited is there, and they're going to install some boiler. And for installation, commissioning, and erection of this boiler, there are around 6,000 employees are used, and there's a project manager by name XYZ. What is going to happen? This and we don't know whether 6,000 employees in a big campus like BHL Tiruchirappalli. We don't know which worker is where. Who has worked so many hours. So what they're doing normally we provide some tracking badges to this through this, so we can know which worker is where, whether he is sleeping, whether he is idle, whether he is moving or not, whether he is working in that particular area assigned to him. Everything we will be able to track. So this track using this IoT application through the smart badges, we can track the level, track the working performance of this labor, and based upon the performance, he can be paid. Next, on safety on the job. Like imagine, like again coming back to our own BHL or any big organization for that matter, like mines, coal mines, etc. Often when it's an emergency and we have to evacuate immediately, that is not possible. We don't know whether everyone is available or there. That time we can't keep an attendance register and take attendance. It's not possible. Or you can ask them to punch out. right? So what is going to do? We are going to have every worker is given a hat. On the hat, we have fitted with some RFID tag, and that tag is going to tell you whether your whether all is all right, or is easy to locate in case of emergency. If there is a sudden landslide or something is there happen inside a coal mine, it will be easy for them to track the location, and that will have during the case of emergency. And okay, this is another case study. Locating capital meters. This is very this has really happened. There is an important municipal concern which was planned to be taken place in a big open air stadium, and what happened is that lighting was, instead of delivering it to one stadium, they delivered the lights to the another stadium. So because of that waste of time, the event was get cancelled, and a lot of so delivering of capital materials has happened, especially in many big organizations. They'll buy tons and tons of steel, other materials, or tons. I mean, they don't know where they kept it over a period of time. That will go in, that will get buried inside the earth, and it will be rusted because it will be kept in open atmosphere. It will be kept, rusting will happen. It will not be all taxpayers' money will go waste. They cannot be used for any other purpose. Just like in railways, we will see like lots of railway track that rails are kept some everywhere. We don't know whether they're going to use it. Like then the cement sleepers, whatever is, they're just lying here and there. But there's no accountability for that. Okay, like this, many companies are leaving their raw materials as such, and because of the constraint in storage. Then loss prevention, like this fire alarms, everything are there, and in case of any vandalism or theft, a lot of times this, especially whenever you lay some pipelines across some places or some remote areas, you would have completed the first 5 kilometers and went for the next. You may be laying that in the 20 to 25 kilometers. Whatever you laid in first 1 to 5 kilometers will be stolen overnight. People who worked in pipeline divisions will understand what I'm talking. So this vandalization can be avoided. Even now we have loss prevention and protection. Like even this yesterday from the news, I heard that they're using drones to capture the leopard which has entered the villages. So all these things are possible, right? So IoT device is going to help safeguard everything. So it's going to sense, process the data, and analyze and control. So this is going to detect, and this is going to prevent a lot of things. So all these devices are available. Okay, and this is another interesting case. This can be even applied in boiler erection. So we have prefabricated structures. To assemble the prefabricated structures, they have used IoT tags or RFID tags to locate and make the right items made with the right items, and to assembly it was very helpful. This is a Leadenhall building in London, which was assembled by using RFID tags. Okay, so overall, what are the benefits of IoT? I may take another 5 to 10 minutes. We are going for cost optimization. New opportunities are there. Greater operational efficiencies are going to be there, and it's going to support a lot of external factors also. So overall, what is the difference? If you ask me, in the process, it's going to be agile and automated, quick and automated. Product is going to be personalized and customized, not like standard products. You go, just like how you buy your stitched shirts, like that is available. Scale of factories is going to be decentralized. In normal factories, what happen? For all decisions, you have to depend upon your boss. The boss has to depend on the MD or the CEO or the general manager or something. But in case of Industry 4.0 or the IoT implemented organizations, the decision making is going to be decentralized. You are the owner of your own booth, own bay, own assembly area, own unit. In supply chain, it's going to be dynamic and predictive. It's highly dynamic. It's going to be predictive. You can predict what is going to happen. What is the forecast will be very good. Then high return on capital investment is there, but investment is going to be more. I accept that, but return on investment is going to be high on your initial investments, whatever we are going to make. Client relationship will be high and direct. This is already be experienced. We started handling classes for the last 2 years in online. Through somehow we have got actual contact with the students. Everything has changed. This pandemic has changed the way we were operating. Then to summarize the tangible benefits, how Industry 4.0 is going to help organizations. From the 3 objectives, what we saw, real-time monitoring is possible on any projects. You are going to cut down your administrative expenses, which this COVID has already proven itself. lot of companies, especially the software companies, they reduce their administrative expenditure to zero, almost zero. Okay, corrective and preventive maintenance is possible. Precise management is possible because every time we are being monitored. Okay, so that's why this is the overall tangible benefits of industry 4.0, and through this we will be cutting down costs, saving the wastages wherever it's possible, and we are going to focus on sustainability, achieving the state of sustainability. So how this industry development is for industry 4.0 is for India. Now let's talk about our own nation. There's a rise in GDP of 18.4%, especially in the manufacturing sector. And India's contribution, the manufacturing industries are going to contribute more to this Indian GDP in the last few years. There is a growth of 8.4% in the 2021 to 22 financial quarter, which is 7.4% compared to the last year. And there is an investment of more than 500 billion is expected annually by 2030. So what are the key facts about GDP is about 1,575 billion. Manufacturing share is around 18.44%. And the global GDP, if you consider, is 2.7%, and whatnot. We are performing very well. And also, as I told, because of this Make in India and all these agendas being pitched by this state and central governments, and availability of cheap labor force and technically skilled employees, the India's GDP, manufacturing industry's GDP has grown a lot, which shows that IoT as changing the phase of the manufacturing industries, especially like technologies like 3D printing technologies. Now we are also even Indian companies started acquiring. A company called Imaginarium is providing 3D printing services. Companies like Hero, L&T, ISRO has started using 3D printing already. The rocket nozzles are being 3D printed, and it's time for us to take a huge leap towards moving towards this 3D printing technologies as well. Initiatives on Industry 4.0. So Indian government is very keen on implementing Industry 4.0 technologies. According to IBEF, they stated that the GDP of India is expected to grow by 2025. It's about 25% through this Make in India and Smart India manufacturing systems proposals. Ministry of Heavy Industries and Public Enterprise Industry, they are in line. They are talking with. They're working with the SMEs to implement Industry 4.0. Andhra Pradesh government has already invested more money on establishing IoT hubs. Yes, and also our own Tamil Nadu government of Tamil Nadu has started its own providing incentives for companies to adopt Industry 4.0 technologies. So in India, when it comes to education institutions and India, as I'm from academic background, in IISc Bangalore, we have a smart factory already set up. Even in NIT Trichy, our professor Duraisalam sir is heading the Siemens Center for Smart Technologies. And in BITS Pilani with Festo Diatec, they have established a center. IIT Madras with General Electric has done. With Alpha TKG, this Japanese technology, IIT Madras has started another unit. Even in VIT Vellore, we have a Center for Excellence in Cyber Physical Systems. We have started with sponsored by Government of India. So a lot of initiatives are taken from the government side to promote this IoT, especially through the budding engineers in academic institutions. Okay, how India will benefit from Industry 4.0. Manufacturing will improve their productivity, efficiency, safety, and performance. SMEs are going to become more agile, and they're going to cut down their costs and reduce the risk. Through the Skill India movement and other advanced training programs, we are going to have a very skilled workforce. Already we have the skilled workforce on cognitive robotics, advanced automation, and industrial ICT tools. Then again, Make in India is going to take with all our new skills, the knowledge developed in the field of Industry 4.0. Through this Make in India initiative, we are going to lead this field of industrial transformation towards Industry 4.0. So we saw this sustainability. We saw this. I just introduced you a lot of use cases and industrial applications of this, real-time industrial applications of this Industry 4.0. So the sustainability on the one hand and Industry 4.0 on another hand. So through this Industry 4.0, we can achieve the sustainability in the way we can. it's up to us to explore the potentials to break down the walls and to achieve sustainability through Industry 4.0. So I stop here. I know I have consumed some extra time. Sorry for that. I'll just stop here to take some questions from the audience side.
Hello, sir. Hello.
Yeah.
Can I know what are the challenges in sustainable development in our country, India? Because we observe that I feel that there is a lot of willpower is required from the government and as our society and the other contributing factors. So in short nutshell, I want to know what are the challenges involved in achieving the sustainable development.
Yeah. So to achieve the sustainable development, it's going to be a win-win situation. Why I call it as a win-win situation is the government is ready to support and come out with a lot of schemes and other things. But it has to be, take for example, the Swachh Bharat for waste management handling, or this Atmanirbhar Bharat. What are the schemes? Government is coming out with a lot of schemes, but whether it's becoming successful or not, then that's in the hands of the people and engineers like us. Okay, Atmanirbhar Bharat is about, they're talking about circular economy. Especially after this COVID-19, when the supply chains were disturbed or they were not functioning anywhere, we started going back to our olden times, like self-sufficient villages were sustained very well. They were able to get the products, food items, everything within the village. They were able to survive. That same way, we were able, with the district to district transportation was cut down, we were able to do everything. So Atmanirbhar means self-resilient. We are going to become self-resilient by adopting circular economy concept. This circular economy concept, I didn't touch it here today, but this is a part of sustainable development. When you do this, when you're becoming self-reliant, or when there's a cooperation between the government and the people, then it's going to be a grand success. But how we are going to follow? Say, for example, if I'm going to talk about making a sustainable product, sustainable design, sustainable manufacturing processes, how many of the industry people are ready to listen to this? No, we have targets. We have to achieve something. I'm going to pollute the environment. No problem. I will pollute because I'm going to get a profit of this much. With this product, what I can do, I can do some carbon trading, or I can give some do some carbon offsetting. But how it is possible? Imagine, like we are saying, no, electric vehicles are going to be the market. I mean, future world. Okay, these electric vehicles run on battery. To get energy for this battery, they are not self-generating. We have to depend upon our coal. I mean, any of our renewable resources or non-renewable resources. So the power generation, from where it comes, it again, we are telling that we are not going to pollute the road, but I'm going to pollute the place where the power is being generated. So some alternates, technology-wise, is also required. Technological barriers are there. Financial barriers are there. Psychological barriers is what I see the most predominant barrier in achieving this sustainability.
Thank you, sir.
Thank you.
Dr. Jayakishna, there are some 2 questions in the chat box, sir.
Sorry, sir. Let me look into that.
No problem. Govindarajan SR asked about, please enumerate the risk in implementation as it may lead to a loss of jobs due to increased automation.
Please enumerate the risk in the implementation as it may lead to loss of. No, sir. Govindarajan, sir, your viewpoint is correct. Like, even I used to think like this: if everything is being, if the technology is going to take everything, then what we are going to do? Okay, correct. Like, when the industries were started, we were comfortable. We learned. I mean, this happens every time. Whenever the industrial revolution is happening, this is going to happen. Only the job nature and the skill level of people is going to change, but people are not going to lose any jobs. I mean, the job the nature of job or the way we do the job gets changed. That's what I believe. Because if we were fearing to, if my father, my previous generation, if they were fearing to learn CNC programming, they would have not, the CNC machine could not have entered the industry. If I didn't learn any programming languages, I could have not made the machines more automated. My next generation will be learning artificial intelligence or machine learning, or just what they think is going to be get coded, and that is going to be programmed. So coding is going to be the future. I mean, as we all know that, we have to accept that. Okay, so technological changes are there. We have to adapt to the technology changes to retain our job. That's everywhere. Survival of the fittest. Maybe I may be sounding so philosophical, but that's going to be the truth, I guess. How Industry 4.0 can help for eco-friendly production to attain sustainability. Okay. So how Industry 4.0 can help for eco-friendly production to attain sustainability? Okay, sir. Dharmesh Silan sir, thanks for the question. Industry 4.0, like Industry 4.0 or some packages what we have. We have to, how we are going to make use of this to attain sustainability or to achieve eco-friendliness. We have learned a lot of lean concepts. Okay, sir. We have learned a lot of lean concepts. Say, for example, through Industry 4.0, if I'm going to say, let's take the supply chain example. To deliver one item from here to, I'm just going to give a very small example for us to understand. Say, for example, there is a place, isolated place in somewhere in Nilgiris or somewhere. No transportation is available to that particular village. In the hilly area, there is a village which has no accessibility. If I want to deliver some vaccination to that particular point, what I can do, if it's a traditional way, I have to travel or I have to walk, I have to send one car, I mean one vehicle over there to deliver the vaccination. So, well, for traveling, we are going to deliver 100 number of vaccination. You're going to send a truck or something for which you're going to fuel the truck and everything is there, right? You know, the transportation point of view, what are the environmental damages, what we are going to do. But rather, if I have a drone and if I can drop the 100 number of vaccinations to the particular village through IoT devices, if I am able to locate a spot where I'm going to drop my vaccination using the drone and everything, the third, I'm talking about the third mile delivery. Okay, so if that is there, then Industry 4.0 is going to able to help sustainability. Okay, so that's one small example. I just want to keep it short. If so, there needs to be huge investment to be done in improving the skill levels to meet the new requirements, as well as the half time for any new skill will become less and less. Obviously, sir, we have to accept this. Govindran sir, I am with you. I stand with you. Yes, of course, huge investments are going to be made. When huge investments are made, we have to hone our skills. This is going to be just like any software engineer, or I'm going to sound like more like a doctor. The doctor has to know what are the symptoms for COVID. They have to know what are the medicines we have to give. If this is a symptom, what medicine I have to give. So like this, we have to keep on developing our skills, because again, survival of the fittest. I know we are there, right? Is there any possibility of minimum or zero marginal cost because of IoT? Is there a possibility of minimum or zero marginal cost? I'm not able to get this question correctly. Zero marginal cost of IoT. No, sir. IoT, yeah, IoT.
Hello.
Yeah, if it's open source, then it's okay.
Hello.
Yes, sir.
Yeah, I just wanted to know about, there is this book from Jeremy Rifkin, which talks about zero marginal cost society and Internet of Things, IoT. So I was talking in that context, basically. Like some of the areas like renewable energy, after a certain time, the cost almost goes, negligible. So in that context, I was talking about in the context of manufacturing, is that the possibility? Like marginal cost, meaning the cost to produce extra parts. Yeah, I was talking about that.
Okay. Yeah, okay. I can help you with that same discussion what you brought out, sir. Sir, in India, we have been trying to use this, expand the usage of, we started to adopt this renewable energy resources a lot. Okay, say it may be solar panels or solar thermal power plants. Even BHL has invested in windmills in Kayathar area, or this, what do you call this, Mahendragiri. I could see a lot of places where BHL has invested on windmills. But do you think they are giving enough return on investment?
No, I think it is. I mean, the cycle is too
Yeah.
long. More than
Cycle is too long. That's where this adoption of renewable energy systems is not at all picking up in countries like India, because what happens is that the amount of power generated is more using these windmills or solar panels. But to store this, we don't have particular, we have invested on, like same like agriculture, we have invested more on crops, we have invested on having a green revolution and everything. But after doing the green revolution, we don't have enough space to store the rice, paddy or the wheat. We don't have enough space to store it. That's where same like energy, we are not able to store the energy produced. That's why they stop the windmills during the peak hours. They stop the windmills, saying that the energy available. But if you have an IoT system, imagine you think about an IoT system, we can predict or we can forecast how much amount of energy, wind energy is going to be there, how much of current I'm going to will be or can be produced by the particular windmill, and whether the capacity is there available with the grid or the distribution center, wherever it is possible to store energy, whether the possibilities are there, how to meet the supply and demand, that we will be able to predict by using this IoT.
Okay, thank you.
Sir, Jai Krishna sir, can you unshare the screen so that the people will be visible?
Yes, sir.
Please unshare the screen. Yeah.
Sure, sir. So I just wanted to give something
Okay,
we have published some books. This books on sustainable manufacturing for Industry 4.0, and you can also read this very good article, a review of Internet of Things, embedded sustainable supply chain for Industry 4.0 requirements. This is a very good article which has got a lot of international attention on this. So please, if you have time, go through these articles sometime. Yeah, so I want to thank all the coordinators and participants for patiently listening to me. Special thanks to Selvaraj sir, Ashman sir, Venkatesan sir, Titus sir, Kevin, Mark Kumar, and all the people who are there here. So now again, I'm going to unshare and let me take some questions if you have.
Dr. Jai Krishna, good evening. I am Balasubramanian from BHEL.
Yes, sir.
See, actually, this IIoT, as you said, it is gaining a lot of moment. In fact, I just wanted to add stuff to your point. Government of India also is putting a lot of efforts into it, and this is being seen as a new thrust area where we can have more business and more, I should say, MNCs are very much interested in coming into, and in that, of course, our BHL also is now pitching into it, and we want to make a big dent into it. So that is what is happening. And see, just for information of everybody, recently, one of the power plant, the total maintenance is taken on this IIoT platform, that is Vijayawada, where BHL has got an order for around, say, 300 crores or so. There, the complete spares management. See, IIoT gives something like the predictive performance of the equipment much ahead, and what is required and what can be required little later. So we have an advanced plan on that, and on which platform we are moving ahead. This is one such example. See, now ministry, since I was also discussing with our heavy industries, there this IIoT has become a main agenda. And this is going to be a future also. I'm very glad that you have you have shown some books and literature on this. So it is really a growing field, and it's very nice that we could, our team should get a lot of inputs about it. And it is in a very nascent stage, I should say, in India. Yes, it has to pick up a lot. Definitely, I think with a lot of inputs and interest, no. And I think now so many courses are coming in the colleges also on IIoT. Yes, so this will give a real opening. See, more than the core engineering, no, such add-ons and which is the need of the hour, definitely put our team rather than ahead of many other people. Really, I just thought I should share my view on this.
So, and that's also an answer to a question raised by Govindraj sir. We have to hone our skills.
Thank you, Balasubramanian sir, for your sharing your thoughts with the BHL. Yeah. And, Mr. Dr. Jai Krishna, he is our general manager at BHL. He was from BHL, and now he is taking out new product initiatives at the corporate level. And he is also chairman and managing director of IL Palkat.
Okay,
so he is the native of Trichy only. From Trichy only, he went there.
Glad to know you, sir.
Our committee member, he is representing mechanical engineering division.
Okay, sir. Okay. Yeah. First time I got the opportunity to meet you.
Yeah, I joined late only, but the subject is a very touchy subject. I am very much keen. So I thought, okay, I should share our views also and get a lot of information. Very nice.
I was not aware of the level of audience, sir. So that's why I kept it very general. Came out with a lot of use cases.
It's a starter, no issue. It's really good.
And Balasubramanian sir, Dr. Jayakishna is awardee of IEI, the IEI Tishnapalli Local Center. He was awarded 2019 when we conducted a production convention with the collaboration of headquarters. He was awarded Young Engineer Award actually.
Very nice, sir.
We awarded him Young Engineer.
Congratulations.
He's a doctorate from NIT Trichy. Another thing.
Oh, I see. Very good.
But Selvaraj, I have a question, Mahajan.
Yes, sir. Please, sir.
Dr. Jayakishna, you made a statement that the ROI, return on investment, for the renewable energy investment is not there.
I'm not saying it's not there. It's not at the level what we expect.
I beg to differ with you. If there was no ROI on these type of investments, 150 gigawatt of power would not be generated from the renewable energy. And that is only solar and wind. If you take hydro also, because hydro is also a renewable energy, there is no such problem, you see. The per unit cost of generation through the solar system is much lower than even the fossil fired power plants. So if it was not there, the investment would not be made by the government and the private sector. Yes, storage is a problem, but the technology has developed so much that the storage is also, getting sorted out, and you are now planning to supply to the grid directly so that there is no fluctuation of power. Okay. So investment return is quite good in these technologies. And today, Balu is there. Nuclear is also now proposed to be taken as a renewable energy.
Definitely, sir. Yeah.
all these are established energy sources, and the return of investment is quite good on these. So things have changed now. Renewal is going to become the major contributor.
Yes, sir. No, I was just talking about that solar panels, sir, and especially the windmills, because in my hometown, all my village lands were given to this windmill installations. And we never see these windmills running. I mean, people told me that it's because of this energy storage issues.
Renewable consists of wind, solar,
accept.
And now also nuclear.
Yes. Can I just say something? This is Gautam Pandit. Actually, the discussion was around the marginal cost that I was talking about. So what Mr. Mahajan said is, I also fully agree with that in the context of creating renewable energy. But the question was more about the marginal cost. Like after 4 or 5 years of installation, will that be free? So I think the chances that it will be free are remote, in the sense the storage cost and the other costs are still going to get incurred. So that was the point actually. So thanks.
Thank you, Dr. Jayakishna. It was an excellent presentation. We enjoyed your presentation. Really, you brought all the technologies in one presentation. All the 9 pillars of IoT, then sustainable development. So much you talked today. What is in my mind is, actually, Indian government is very much thinking of improving this IoT, as Balu told, IoT, this industry 4.0. They separately formed a cell in NPC and all. What India, even all these initiatives, our manufacturing share is 3% of the world. But compared to China, it is 28%. So we have a room of development. There is a very big space for us to develop a lot. Even we go to 10%.
A giant leap is required.
Think of this, these 3 times will improve our production level. And this is a long road we have to do it actually. Thank you so much. Really, it was a wonderful knowledge treat for all of us. It was an eye-opener for all our engineers, and people from all over India participated in your program. And people from Sri Lanka, Nepal, and all participated. North India, Middle India, South India, and all the participated professional institutions. Dr. Our Magajan for a former executive of BHL, and Dr. Edwin Brown, Dr. Gandhia, Dr. K. Sivasamy, and Engineer Bharat Chandra. I can go on telling the name. So many people and participated. We are very much thankful for all those people for their participation. Now, moving to the next agenda, I call upon our Honorary Secretary, Dr. Kevin R. Kumar, to announce the next week's program. Dr. Kevin R. Kumar. Hello.
Good evening to all.
Yeah. Welcome.
Thank you, sir. Sir, good evening to all. First of all, I like to thank our today's speaker for sharing a wonderful lecture. And now I would like to announce the next week's lecture program. It is on the topic autonomous ocean monitoring vehicles. And the speaker is Dr. Venkatesan R., scientist and head, Department of Ocean Observation, National Institute of Ocean Technology. It is under Ministry of Earth Sciences, located at Chennai. So he will be the next week's speaker, and I kindly request everyone to participate, and you can also invite your friends and colleagues for this lecture program. Thank you, sir.
Thank you, Dr. Kevin. Again, and you know that next week's speaker is an eminent personality. He is a council member of All Day. He has got a lot of awards. He has done a lot of work in our Indian, innovation and creativity. He has done a lot of work for ocean engineering, and he has got so much awards. And he is one of the renowned scientists with us. He is a former chairman of Kalpakam, that Kanjipuram local center. He is a very good. Again, he is going to be a very good, lecture on next week. I require all the participants again join. We will communicate suitably. And moving on to next agenda, I call upon Dr. S. Karupusamy, former chairman, to propose vote of thanks. Dr. Karupusamy, sir? Hello? Karupusamy, sir, is there?
Audible?
Yeah, audible. Yeah, please. Audible, sir. Please go ahead.
Hello.
Some signal disturbances, sir.
Yeah. Good evening to all. Good evening to all. It is a privilege and honor for me to propose vote of
Sir, you are not audible. I think, sir, there are some bandwidth issues.
This is.
Yeah, there's a bandwidth issue, I think.
Let everyone switch off the camera. Bandwidth available will increase.
Am I audible?
Yeah.
Hello?
Yeah.
Hello?
Yes, sir. Audible,
Hello.
please talk. Yes, sir. Karupusamy, sir, please. Dr. Karupusamy, please.
I am seeing in my network, it's showing high only.
Okay, now you go ahead. Go ahead with your vote of thanks. Yeah, please. Karupusamy, sir? என்னாச்சு இவ்வளவு வர முடியலையா? சரி ஓகே, நான் பார்த்து க்ளோஸ் பண்ணிக்கிறேன். ஒரு நிமிஷம். சரி ஓகே. சரி. பேசுறேன். பாலு சார். பாலசுப்ரமணியம் சார்.
Yes, sir.
Yes, sir. You propose vote of thanks. Our network cut ஆயிடுச்சா?
Okay.
Opportunity for you to propose vote of thanks. Please make it.
Dear eminent speaker, Dr. from VIT, and my dear members of IEI, warm good evening to all of you. In fact, this IIoT is a very, very nice and niche subject, which is the need of the hour. So I really thank the speaker for bringing out the salient points and importance, and also the future, what is going to be. And really, we thank our speaker for bringing out all the aspects, and also giving corroboration to other aspects like cost and the future of this. So it is definitely, I am sure, it will be very useful for all our members, and it will also give kickstart and another line of thinking of putting it in the syllabus or curriculum or in the industry part also, how to move forward and grab the new opportunities. As Government of India has also given a lot of trust, this subject makes a very big impact on all our engineering fraternity. So I must thank the speaker, and also I must thank all participants who have joined in large, not only from India, from abroad also. I am really very happy to see this. So and making this lecture a useful one for all concerned, because I know everybody will spearhead this to their team and it will just sprout as a big tree. So this message will go across to everybody and it will have a fruitful result. So finally, I thank you all for the coordinators and the participants and making this event a very, very successful one. Thank you very much, my dear friends.
Thank you, sir. Thank you. Thank you, Balaswaran sir. Actually, other professional bodies of the Indian Institute of Computer Society of India, Tiruchirappalli chapter, Indian Institute of Welding, Tiruchirappalli branch, Indian Welding Southern Indian Welding Society Southern Zone, and Indian Institute of Metals, Tiruchirappalli chapter, Indian Institute of Industry Engineering chapter. All those members of those institutions also joined us. We thank
very nice.
so much.
Yeah.
That actually we are not shared.
Yeah.
They are thankful to those people who joined.
Definitely for all the participants from all the memberships. Yeah.
I also want to one more information I want to share. Our India is having more than 65% of working people, and this is an opportunity for us to grab this century. Not only that, more than 1,000 Western companies are interested to install their base in India. That is one thing after this COVID and all, because of their non-belief with some other countries. And this is the opportunity we have to grab, and we have to move on our improve our GDP, $5 trillion, as well as other GDP of this world share of our production and all. It is an opportunity for all of us. Thank you so much, Dr. Jai Krishna, Dr. Engineer Balasubramanian sir, other S.M. Magajan sir, all the people, eminent people from all over the India, other Nepal and Sri Lanka and other people from the globe. Thank you for joining us. With the permission of this thing, we will close it, sir. Shall we close it, sir? Yes, sir.
Yes, sir.
Okay,
Thank you all of you. Thank you.
Thank you, Balu sir. Thank you, sir. Thank you for joining.
Thank you. Thank you all. Right.
Thank you. Good night, everyone. Good night, everyone. Thank you for joining us. Thank you.
Good night. Good night. Thank you.